So we're going to go into our second day of factoring. This time we're going to focus on grouping. So that would be our third step here on our objectives for 6.1, factor polynomials by grouping. So we've got some math problems, and we're going to look at this one right here in particular that involve common binomial factors. So we've got one term right here, 9x times x plus 3, and we have another term right here, 2 times x plus 3. And what we have in common is this binomial, x plus 3. Now, that is in each term, it's in common, so we can factor out that as a common factor. So we're going to have x plus 3 as our common factor, and that x plus 3 is being multiplied to the 9x, and is being multiplied to this positive 2. So all we did was the greatest common factor, only this time our greatest common factor was a binomial. Now this one has a little bit of a problem in here, that there's no number written right here. So we're going to put a 1 in front of the second binomial. So that way, when we factor out that common binomial of m minus 7, we see that it's being multiplied to the 6m squared right here, and it's also being multiplied to that negative 1. So we have a negative 1 in that second factor left when we factor out the m minus 7. So sometimes we're going to have binomials that are in here that look like they're similar, but they're not exact. So that 7 plus y is not the same as y plus 7, except that they do mean the same thing. I can change their order because of the commutative property of addition. So I can have that 8y, and if I put it in descending order of exponents, that 7 plus y can be written as y plus 7. We'll just leave the rest of that the same. Now the binomials are the same. So I can factor that binomial out, y plus 7, and it's being multiplied by the 8y and the 5. So there's my factored form of that polynomial. But sometimes the commutative property is not going to help. For example, in this one, I have m minus 6 and 6 minus m. Even if I change this one into negative m plus 6, they're still not the same. But if I were to take this one and do one more thing to it and factor out a negative 1, now m minus 6 and m minus 6. So I'm going to factor out a negative 1. So I'm going to rewrite that as 7m times m minus 6. And because I factored out a negative 1, I'm going to multiply it with that 2. So that becomes 2 times negative 1 is negative 2, m minus 6. So now I have a common factor of m minus 6. And that's being multiplied to the 7m and the negative 2. All right, this is where you get to try it. You're going to pause the video, and each of you work on these 4 problems here and factor by grouping using the examples that we've already gone over. When you've gotten an answer, go ahead and start playing again so you can check your work. I know you guys can do it. Okay, welcome back. So these are the answers that I got. I bet you got the same thing. If you didn't, go back and look at the examples and try to figure out what you did wrong, and let's move on. So far we've been given them where the binomial's already been grouped up, and we just have to identify it and factor it out. But when we're given 4 terms, we need to do the grouping ourselves. And we're going to group them by 2 terms and then factor each set separately. So that is going to show us if they have a binomial in common that we can factor out. So I'm going to look at this group and then I'll look at this group. So x cubed plus 4x squared has an x squared in common. And then if I factor that x squared out, I'm left with x plus 4. And the 3x plus 12 has a 3 in common. And when I factor a 3 out, I'm left with x plus 4. Now it looks like what we were just doing. So x plus 4 is my common factor. And it's being multiplied to the x squared and the 3. And that's our factored polynomial. Let's try that again on this one and this one. So I put them in a couple groups. The first two, 2x cubed plus 6x squared, has a common factor of 2x squared. That leaves me with x plus 3. Oh, x plus 3 doesn't have any common factors, so what we have to do is the common factor of things that don't have one is just 1. So we're going to factor out a 1, which still leaves it as x plus 3. But that's good because now the binomials match. So I have x plus 3 times 2x squared plus 1. And we want to include that 1. It's not nothing. One more time. We've got 15m squared minus 15m. And this was minus 6m plus 6. So that first pair, 15m squared minus 15m, we're going to have 15m in common, leaving us with m minus, and 15m divided by 15m is not nothing, it's 1. So we want to write that 1. Now when I'm factoring this one, I'm going to factor out a negative number because I want my binomial to start with an m. So I'm going to factor out a negative 6, and that gives me m minus 1. So now my binomials match. So I factor out the binomial, m minus 1, and it's multiplied by 15m minus 6. I could have done that and done that. All right. Once again, we're at that you try section. So once again, pause the video, work these out. Remember, you're going to be grouping them and then finding the common binomial to factor out. Pause the video, and when you're ready to check your answers, come on back. All right. So there's the answers. I hope you did well with those. So we're going to apply the same sort of knowledge to something that we might do in geometry, and that's finding the area of a given polynomial. Now, this one gives you a figure, and it says, what's the width of the figure to the right? Now, this is a rectangle, so we know that the area of a rectangle is the length times the width. Well, they gave me the length is x plus 3, and they gave me the area, 4x squared plus 12x plus x plus 3. So I need to find the width. So let's factor that. If we take 4x squared plus 12x plus x plus 3, there's a common factor of 4x, and we get x plus 3. And then here we have a common factor of 1, and that's x plus 3. So the other factor that we already know, x plus 3, is the length. So 4 plus 1, 4x plus 1 is the width. Now it's time to show what you know. So you have an assignment, and it's on, if you go into your textbook, it's on 273 to 275. It's numbers 45 to 65, the odds. Make sure you show your work.